Hello and welcome. We're going to look at the bonding in acetylene according to valence bond theory, and we're going to have to form those hybrid orbitals. So we've already said in the last lecture that we're going to need sp hybrid. So there's an s orbital and there's a p orbital, and in hybrid orbitals we're going to go ahead and we're going to blend them together. So we're going to form combinations of them, and we've already seen that one of them essentially points to the right and the other one essentially points to the left. And so we've got these orbitals here that point in the correct directions to make the bonds. So the carbon has the orbital diagram, so that looks like this. So there's the 1s, there's our sp hybrids, so we saw that in the last video, and these are our unhybridized 2p orbitals. And the hydrogen has just a single electron in a 1s orbital. So we're going to go ahead and we're going to combine them now to come up with a bonding. So over to the next slide. All right, so let's start by drawing one of the carbons. We know it's got sp hybrids. The sp hybrids, basically one points to the right and the other one points to the left. Isn't that crazy? So those are my sps, and there's my other sp in red. The hydrogen has got a 1s orbital, and the 1s orbital right is a beach ball shape, and it's got one electron in. So perfect. So that's our first bond here, and this is what they call a sigma bond because you've got that head-on overlap, and if you look alongside, it just kind of looks like a circle. So that is one of the bonds. So if you sketch acetylene at the top right, so this is what we're looking for. All right, so we have accounted for this first bond here. So now we need to find this first bond here between the two carbons. And so there's our carbon, and again, it's got those sp hybrids. So it's got one that points to the left, and it's got one that points to the right. So they've got that perfect 180-degree geometry. So here's an sp, and in red over here, here's my other sp. So notice there that those two sps have overlapped, two electrons, two orbitals, so that's giving me my bond there. And again, that is a sigma type bond. And if we go ahead and we look at the other side of the molecule, then we've got the carbon and the hydrogen. So the hydrogen's over here. It's got itself a 1s orbital with one electron in, so they can just overlap like so. And that gives us our third sigma bond. So that is our sigma framework here. And I should go ahead and just check mark up here. And remember, the first bond between a pair of atoms is always sigma. And that is because the head-on overlap is the strongest kind of overlap possible. Now, we haven't accounted for the double bond, the two extra bonds between the carbons, the double and the triple bond, I suppose. And so that's going to come from the fact that we've got unhybridized p orbitals. And those p orbitals, if I just go ahead and redraw them, we've got a pair of p orbitals that are orthogonal, so they're at 90 degrees to the molecular bond between the hydrogens and the carbons. So I'm going to draw one above and below, and they got two electrons in, so I got one electron, I got one electron. They're kind of overlapping and making that bond. We call that a pi bond when they overlap side on. And we've got another bond to account for as well, so we also have another pair of p orbitals. And again, those p orbitals are at 90 degrees to those hybridized orbitals, and so they're going to overlap side on. We've got a couple of electrons in each orbital there, so now we've got two electrons overlapping in two orbitals, and of course that is another example of a pi bond. So we've got a sigma bond, the first bond between each pair of atoms, and the second and third bond between the central carbons are pi bonds, and that's the bonding in acetylene. Let me see if I can find a nice picture of that. So here's a nice image from our textbook. Notice they're using arrows instead of dots there, but that's totally fine too. So here's the carbon over here. Let me go to a different kind of pointer. Here's the carbon over here and the hydrogen here. So there's that 1s orbital. There's that sp hybrid that they've drawn in purple. They overlap head-on, so that's the sigma bond. So I can go ahead and sketch that. That's a sigma bond right there. So that's the first bond in the molecule we need to account for. And then between the one carbon and the other carbon, they use the sp hybrid. That again points at 180 degrees. So this one and this one are 180 degrees apart. They overlap head-on, so that is a second sigma bond here. And then we've got the carbon and hydrogen on the other side. So there's the carbon, there's the hydrogen. So it's just the mirror image of the left-hand side. We've got that sp hybrid that points to the right, and we got that circular 1s orbital. And so again, we've got ourselves our third sigma bond right here. And notice here they've overlapped those p orbitals. So you got a p orbital sort of above and below, and they're overlapping and giving you this this pi bond right here. And then you got one that's sort of in front and behind, overlapping side on and giving you that second pi bond right there. And so that is the second, where the two of the pi bonds there in the molecule. So that's the bonding there in acetylene. Isn't that awesome?